Alright, hello Algebra 2. So this is trig functions in right triangles, and if you're looking at the numbers, you may notice I skipped chapter 11. It's not because I don't like chapter 11. Couple of reasons. First of all being that there are a lot of graphs and a lot of charts in chapter 11, and while those things are fun, they are also not the easiest thing to explain via whiteboard, and I would be constantly having to do this and hold it up and make sure you could see what was going on, so that's one reason. Another reason is I know quite a few of you are planning on taking trig next year, and if you are planning on doing that, this chapter of stuff is going to be more useful. Also, if you're planning to take the ACT at some point, this chapter is going to be more useful, and if you're not planning to do either of those two things, just trust me, this is easier to explain over whiteboards. And there's my cat. Say hello. Alright, so first bit of this is a little bit of review of what we were doing in geometry around this time last year. So some of these probably look familiar. So SOH CAH TOA, standing for sine, cosine, tangent. Hopefully that's not new. So sine is your opposite over hypotenuse, cosine is your adjacent over hypotenuse, tangent is your opposite over adjacent. That part's not new. This part is new. So your three new trig functions are your cosecant, your secant, and your cotangent, and you may notice if you're looking at your fractions that they're basically just these ones flip-flopped. So your sine and your cosecant, those are your reciprocals of your fractions. So those are something that I would take a sec, pause the video, and jot down, because really the big thing is just not getting these new ones flip-flopped around, because you would think that the one that starts with C goes with the one that starts with C, but it doesn't, so I would just go and jot those down real quick. And listen to me, you did that. Then we're actually... Alright, you need to get out of the way now. Hi. Okay. So what we're doing with that is we're going to be taking a triangle and we're going to be finding our 6 trig functions. And again, really the big thing with this part is just not getting mixed around which one is which. And you may notice if we're looking at this triangle, we have a little symbol you might not be used to seeing, and that little symbol is theta. So circle with a little line through it, watch out for, that's not the same thing as this, which we're used to seeing mean no solution. This is just another variable. So if that's confusing, just pretend it's an A or a B or an X or a Y or any other variable. It's just another one of those Greek letters. So if we want the sine of this angle, you may notice we only have 2 sides. So the first thing we're going to do is we're going to find our missing side. Now, if you happen to remember that 3, 4, 5 triangles are a thing, you can save yourself a little bit of Pythagorean theoreming. I don't know if you can hear that my cat's skidding around on the floor out there. Okay, what was I saying? If you happen to remember that 3, 4, 5 triangles are a thing, and therefore this is just a multiple of 3, that's a multiple of 5, so then that would make this 8. Cool, you can save yourself a little Pythagorean theoreming. If you didn't happen to remember that, that's fine. You just plug in a squared plus b squared equals c squared. I really shouldn't use b's in the same thing as 6's, because we're turning this to 36 right now anyway. So b squared equals c squared, which is 10 squared. Not bad. 10 squared is 100, and now we're just subtracting at 36. That gives you 64. And the square root of 64 is 8. And again, if you happen to remember that 3, 4, 5 triangle little, trick there, then you can save yourself a little bit of this. This works just fine. Okay, so then we're making some fractions, and your sine is your opposite over your hypotenuse, and watch out for your opposite and your adjacent are relative to which angle we're looking at. So if we're looking at this angle, your longest one's always your hypotenuse. Your opposite one is your one that doesn't touch this angle. So it's not this one or this one, it's this one. So this is your opposite, and that makes this one your adjacent. So then if our sine is our opposite over our hypotenuse, we're really just filling these in. And your cosine is your adjacent over your hypotenuse. And your tangent is your opposite, which is 6, over your adjacent, which is 8. And boom, that's those 3. So, and I'm not going to be terribly picky about whether you leave these as fractions, whether you turn them into decimals, or whether you reduce those fractions. Not the main point here. Not the main point here, and not what we're going to be using it for later. Because eventually we're going to have variables in this, and you won't be able to reduce them anyway. Okay, so if you happen to remember that these three are just these three flipped, then we're just taking this fraction and flipping it. So we got 10 over 6. We got 10 over 8. And we got 8 over 6, and that'll work as long as you always keep these three in the same order as these three. So as long as we're just going straight down in that order, you can just flip-flop these first three to get these last three. And again, fractions, decimals, whatever. Because those are about to be variables anyway. But before we do anything else with that, make sure your calculator is in degrees, because all of this gets messed up if you're not in degrees. So the way to make sure your calculator is in degrees is if you see a little thing that says DEG somewhere, you're probably in degrees. If you're not sure, go ahead and punch in the tangent of 45, and you should, if you're in degrees, you should get 1, because your tangent is your opposite over your adjacent, and if these are 45s, you've got yourself an isosceles triangle, so whatever this is over itself should give you 1. So if you punch in tangent of 45 and get 1, you're good. You're in degrees. If you don't get 1, you're going to want to find your degree radian button and switch that. If you're not sure where that is, maybe take a picture of it and I'll try to help you find where it is. It's in a different spot on every single calculator. Or you can just probably Google whatever your calculator type is and how to change from radians to degrees. But you do want to make sure you do that before you do anything else. If you're using the one that's on your calculator, it should have a little button like mine here says radians right now, because that's what I'm not in. So if I click it, it says degrees, and if I click degrees, it's in degrees, and it says little degrees over here. I don't know if you can see that, it's kind of blurry. So that's where it is on the one that's probably on your calculator. It's probably in a similar spot, so look for something that says radians, degrees, or R&D, or RAD and DEG, something along those lines. And make sure you do that before you move on. So if you haven't done that, pause the video and do that now. If you're still watching, I'm going to assume you did that. Okay, because what we're about to do with this is we can use this to find either a side or an angle that we're missing. So as I said, we're going to have variables. So when I'm setting up this fraction, you want to make sure you use either sine, cosine, or tangent. Technically, you can use either secant, cosecant, or cotangent as well. Those buttons are probably on your calculator somewhere, but might as well just stick to these three for now. If you want to get fancy with it, you can. So in general, if I've got my opposite side and my hypotenuse, we're probably going to want our sine, because part of SOH CAH TOA, opposite over hypotenuse, because we have our opposite, we want our hypotenuse. Now, technically, you could also use your cosecant and set it up that way, as long as you have a cosecant button on your calculator. That'll work too. I'm going to stick with sine. So I'm going to set up a fraction and say the sine of 32 equals my opposite, which is 5, over my hypotenuse, which I'm looking for, so I'm going to call it x. Okay, but the sine of 32 is just a number, which is why I said you want to be in degrees, because now you're going to take your calculator and punch in the sine of, where's my sine button? Where's my sine button? There's sine of 32. And you get about 0.5299. If you didn't get about 0.5299, you're probably in radians, switch to degrees. Okay, so now we got 5 over x. X is on the bottom of my fraction. So we're going to take both sides, multiply them by x. These x's are gone, so now I got x times 0.5299 equals 5. We're going to divide both sides by 0.5299, so now we're just solving for x. So 5 divided by 0.5299 gives us about 9.43. And in general, things aren't drawn to scale, but if we're looking at this, yeah, 9.43, that's a reasonable thing to get. Because our hypotenuse is going to be our longest side, that's bigger than 5, but we're still in the same ballpark. We didn't get like 28 or something. You'd only get that if that was a really skinny angle. So you want to make sure you end up somewhere in the same ballpark as your other sides, and your hypotenuse should always be your longest one. And really the big thing with these is just figuring out, do we want to use sine, do we want to use cosine, or do we want to use tangent? So if we're looking at this one, if I've got 70 degrees here, if I'm looking at this triangle, I've got my opposite side, well, I want my opposite side, and I've got my adjacent side. So opposite and adjacent, TOA. So we want the TOA part of SOH CAH TOA. So our tangent of 70 is going to be your opposite, which is x this time, over your adjacent, which is 18. And again, technically you could also use a cotangent there as long as you have a cotangent button somewhere on your calculator. I'm going to stick with sine and cosine and tangent, but you can use either. Okay, so now I want the tangent of 70, and again, make sure you're in degrees. Tangent of 70 is about 2.747. And I'm rounding these. In general, 3 or 4 decimal places is fine. That'll get you close enough. I mean, there was something after this 9.43, but close enough. Okay. And then we're just getting rid of dividing by 18 by multiplying by 18. So we're going to take that times 18. Calculator difficulties. There we go. Okay, 49.4. Alright. And again, if we're looking back here, we're in the same ballpark, 2 digits, we're in the same general area. This is a bigger angle, so that's going to be a smaller one. So that means this side is going to be quite a bit shorter than this side. So yeah, we're in the right ballpark. Alright. So that's sides. The other thing we can do with this is we can use it to find angles. And again, keep your calculator in degrees. Do not change it to radians. We will eventually get to what radians are, I promise. Not yet. Next section. I think it's the next section. Okay, same sort of idea with angles. So if I want to find, again, that's just a variable theta there. So if I want to find that angle, I want to look at the sides I've got. So this time I've got my adjacent side, and I've got my hypotenuse. So that makes this CAH, because CAH makes this the CAH part of SOH CAH TOA. So your cosine of, this time we don't have an angle, so I'm just going to leave that as a theta, is your adjacent side over your hypotenuse. Okay, I mean, you could turn that into a decimal. I'm going to leave it as 4/12, because what we're about to do is, if we want to get rid of a cosine, we're going to inverse cosine. So what you're looking for on your calculator is a button that has a cosine and then a little -1 there. Or the other thing it might look like is there might be an A and then a cosine. So depending on what your calculator looks like, it might be this, it might be this. It could also say arc cosine, that's what the A cosine stands for. So you want one of those things. Depending on what calculator you have, it might be a shift and then your regular cosine button. That might be where it is. Again, if you can't find it, just send me a picture and I'll help you find it, or just Google where is said button. If you don't happen to have that button on your calculator, feel free to pull up a calculator on Google and that one will have it. Alright, and then we're just inverse cosining 4/12. So I want the inverse cosine. So on mine it's shift and then cosine of 4/12. So I'm just going to leave that as a fraction. If you want to reduce your fraction to 1/3 or change it to a decimal, that's fine too. Just a heads up that if you decimalfied that, again, just stick 3 or 4 decimals on it, and that gives you about 70.5. Okay, which again looks like we're in the right ballpark, because this is a bigger-ish angle, because that's a pretty small side hypotenuse there. 70 degrees. Okay, we're in the right ballpark. Okay, one more of those. And again, the big thing here is just figure out, do we want sine, do we want cosine, do we want tangent? So if we've got our opposite side, and we've got our adjacent side, O, ah, so again, the OA part of SOH CAH TOA, so we want to say the tangent of theta is your opposite side, which is 11, over your adjacent side, which is 16. So then again, I'm going to want the inverse tangent this time of 11 over 16. So shift tangent 11 over 16. About 34.5. And again, that's in degrees. Not something I'm going to be terribly picky about, but we do want to get in the habit of writing that little degree sign there so that when we get into degrees and radians, we know which one we're in. Just like you want to make sure you know whether you're talking about inches or centimeters, whether you're talking about pounds or liters or grams or whatever it is. This is just another unit, and I'm not going to mark you down for it, but do try to get in the habit of throwing that degree sign on there. Okay, and 34 degrees, yeah, that looks about right. That's definitely a smaller angle than this one would be, because 11 is shorter than 16. Okay, we're in the right ballpark. Right, and that is pretty much that. So again, this was probably stuff that you remembered from geometry. Next section, we're going to get into the stuff that's new. Just want to make sure we still had a handle on these basics first before we start piling some stuff on top of it. So go ahead and check out the homework in the description, and I'll see you in the next video.